So following on from the previous video, we got to this stage here where we managed to work out the vector PQ, which was given by this. So we managed to work out this vector PQ. So now the shortest distance that exists between two lines occurs when this is at 90 degrees and this is also at 90 degrees. So the shortest distance occurs when we need to make the demand that PQ dots it with this vector here, which is this one here. So we need to make this demand here to be equal to 0. So that will ensure that by making this demand, it will ensure that this would be at 90 degrees. And then we also need to make the demand that PQ, the vector PQ, dot it with the vector here. So this vector here, so dot it with this 1, 1, 3. We need to make the demand that the dot product here equals 0. By making this demand, we will ensure that this will be at 90 degrees. So the shortest distance occurs when this is 90 degrees and this will be at 90 degrees. So in short, we need to make this demand and we need to make this demand. So in the previous video, we managed to work out PQ. Remember, the vector PQ is given by this. So hang on. So now we need to make these two demands. So PQ is given by this. PQ is given by this. So now it's just a matter of processing this. So it would be the dot product will be this times this, which will give you this, plus this times this, that will then give you this, plus this times this, that will then give you this. And then for the other one, it will be this times this, that will then give you this, and then this times this, that will then give you this, and then this times this, that will then give you this. Well, going back to the other one, so remember this thing here gave us this. So now tidy this up. So looking at the S, you've got one S and another S here, and then you've got 6S here, so that will then give you 8S. And then looking at the T, you've got negative 1, and negative another 1, and then negative an extra 4. So that will give you negative 6T. And then you've got your 1, blah, blah. Tidy this whole thing up. That will then give you this. Now, earlier we did this. That took us to here. So now tidy this thing up. That will then give you this. So now it's just a matter of solving this and this. So we are looking for a time t and a time s where the shortest distance will occur. So remember, the shortest distance occurs when PQ when this is at 90 degrees and this is at 90 degrees. So we are really looking for a time t and a time s when this thing occurs. Okay, so we need to work out s and t. So you solve it by you've got simultaneous equations here. So solve these two equations. So let's times everything here by 4, times everything here by 3. So times everything here by 4, that will then give you this. Times everything here by 3, that will then give you this. Get this, take away this, that will then give you this, and then put this back into here, blah blah. T then becomes this. So now we've got S and we've got T. So what that means is this. Remember, we've got a time S and a time T. So what that means is this. Looking at S here, you start at this point here. So hang on, let me think. This here is S. This line here is S. So you start at this point here. Well, in our case, S is negative 1. In our case, S is negative 1. So this vector here normally goes in this direction. But then because S is negative 1, it will be in this direction. So it would take us to this point here. And then T, remember the shortest distance occurs when S equals negative 1. When this time here is negative 1, the shortest distance occurs when this time here is negative 1.5. So when you come to read line 1, so remember line 1 is this line here, you start here, and then normally this vector here takes you in this direction. But but because the answer is -1.5, it would be this. So normally, let's just imagine normally our vector is this. So normally, let's just pretend that this vector here is this one here. So because t is -1.5, so 1 here, 2 here, 1.5 will be here. So that will be, you see, the shortest distance occurs where the shortest distance occurs when time here equals -1 and time here -1.5, which takes you to this point and this point. Remember, P, this is our P here. P is actually here. This is our P here, and this is our Q here. So this is our Q here. So the shortest distance is us trying to calculate this. So we need to process the magnitude from P to Q. We need to process the magnitude. Okay, so our next step is to process this magnitude here. So remember, we know it occurs when time equals -1 and -1.5. So let's compute this this magnitude. So computing this magnitude, remember, s equals this, t equals this. So put it into here. Put it into here. This whole thing here will then become this. Put it into here. Blah blah blah. This whole thing here will then become this. Now factorize the 3/2, so that will then give you this. So now it's just a matter of working out the magnitude. So the magnitude of this will be blah blah. The magnitude will be given by this. Okay, so that's your distance. Your distance is given by this.